Hi, I am Puru Ojha and I am presenting our work titled ACMGVR Architecturally Consistent Mazes for Games in Virtual Reality. With ACMGVR, we have developed a novel framework for producing architecturally consistent mazes with multi-directional capabilities, which provide you with an option to go in both forward and backward directions and produces distinct, customizable, and scalable virtual mazes for physical areas exceeding 4 into 4 meters. Virtual environment can be explored in two major ways: natural locomotion and supernatural locomotion. As the name suggests, natural locomotion allows us to travel the virtual environment in a way that replicates our natural gait, while supernatural locomotion provides us with the capability to traverse a much larger virtual environment by providing us supernatural locomotion abilities. There are some limitations to the natural locomotions because they are limited by the available physical space. To tackle these challenges, various techniques like overlapping architecture have been developed. They procedurally generate a virtual environment which overlaps itself in the real world while giving the perception of a normal environment to the individual experiencing them in the virtual reality. We have developed an overlapping architectural technique which produces such overlapping environment while keeping the natural presence of the individual. Our mazes consist of two fundamental building blocks: section walls and connecting corridors. Section walls are two parallel walls, and connecting corridors connect various section walls together to produce the architecture of the overall maze. We start from the place where the player is present. Then we check the available directions to produce the maze by doing depth first search to check the distance to boundary from that location. Three directions: forward, 90-degree right, and 90-degree left are checked. Random directions are chosen from the available directions and section walls are placed at these chosen directions. The section walls are then connected by connecting corridors. The relative positions of the walls and the corridors are saved in a graph data structure that represents the overall architecture of the maze. Triggers are present in the section walls, which determine the position of the player in the direction of the player movement between the whole architecture of the graph. We save the overall architecture of the maze, which provides us with the capability of traversing the maze in any direction desirable. As shown in the following diagram, the player is shown as blue cylinder and a smaller white cylinder indicates the forward direction of the player. They take 4 left turns in image A to D. It's clearly visible that the section A and D occupy same physical space while representing different sections of the maze. Thank you.